with the following members, and we are going to be tackling all about the chlor-alkali industry.
In this part, we will be talking about a brief description and history of the chlor-alkali industry. Salt use may be as old as written history itself, maybe even older. Be it as a simple preservative or a flavoring to dishes, to a form of remuneration or currency to ancient Roman soldiers, the humble halite has always been viewed upon as a precious commodity. But at the advent of the industrial era, it took on a much larger role to compensate for humanity's endless needs, further exacerbated by industrialization. It was so important that a whole industry was built upon it, the chlor-alkali industry. But what is the chlor-alkali industry? Chlor-alkali industry centers itself on the chlor-alkali process, a process which employs brine, a salt solution, water, and electricity. In a large vessel separated by a semi-permeable membrane with two giant electrodes situated to each division, brine is allowed to flow in the cathode and water in the anode. As electricity is allowed to flow in the electrodes, chlorine gas is produced in the brine side, while hydrogen gas and sodium hydroxide solution is produced in the water side. The overall reaction for the process is as follows. 2 moles of sodium chloride plus 2 moles of water goes to form 2 moles of sodium hydroxide solution, hydrogen gas, and chlorine gas. Now there are 3 variations for the chlor-alkali process, and these account for the 3 different types of semi-permeable membranes utilized for the chlor-alkali process. One is the diaphragm cell process, which uses an asbestos filter. Another is the mercury cell process, which employs a sodium-mercury amalgam. And the membrane cell process, which employs a membrane cell derived from a polymer. Of the 3 variations, the membrane cell process is the most widely used, safest, and has the least energy consumption. Prior to these modern methods of producing hydrogen gas, chlorine gas, and sodium hydroxide solution, many historical undertakings have been went through to produce these components. In 1838, Christian Friedrich Schoenbein first produced hydrogen gas from a fuel cell, which is the starting point for the industrial production of hydrogen. In 1866, the Weldon process for producing chlorine gas via magnesium dioxide and hydrochloric acid was first utilized, and during the 1870s, the Deacon process for producing chlorine gas via the direct catalytic oxidation of hydrochloric acid with air was first used. Now, during the late 1880s, the diaphragm cell process was first utilized to produce sodium hydroxide solution. In 1892, the Kastner-Kellner process, or more widely known as the mercury cell process, was first used to produce sodium hydroxide solution. And in that same year, the first industrial-scale production of hydrogen gas took place.
The chlor-alkali industry is highly significant for various businesses and applications. With a large variety of use, the chlor-alkali industry is dominated by certain companies in which we will tackle in this segment. Firstly, we will take a look at global companies who have made their mark in the chlor-alkali industry. In accordance with the report of Markets in 2016, the major producers in the said industry are Olin Corporation, Solvay SA, Tata Chemicals, Occidental Petroleum Corporation, Axiall Corporation, Hanwha Chemical Corporation, TASA Corporation, Tronox, and more. Now, let us go in depth with some of the companies mentioned. Firstly, we have the Olin Corporation. Olin Corporation is an American manufacturer of ammunition, chlorine, and sodium hydroxide. It is based in Clayton, Missouri, and it traces its roots to 2 companies, both founded in 1892. Franklin Allen's Equitable Powder Company, and the Matheson Alkali Works. Henceforth, the company has been around for over 129 years. Allen created the company for the purpose of supplying the area's coal mines and limestone quarries with explosives. The main products that they offer involve copper alloys, ammunition, chlorine, sodium hydroxide, epoxies, vinyls, and hydrochloric acid. Let us move forward with Solvay SA. Solvay is an international chemical company founded in 1863 with its headquarters in Brussels, Belgium. It is founded by Ernest Solvay and his brother, Alfred Solvay, to initially produce sodium carbonate. Thus, this company has been standing for 150 years. As time went on, the company diversified into two main sectors, which are the chemicals and the plastics. In 2015, it is ranked among the top 3 manufacturers with 145 sites in about 53 countries. Their main products are amines, antioxidants and stabilizers, barium and strontium derivatives, calcium and magnesium derivatives, composites, flavors and fragrances, chlorine derivatives, lithium derivatives, chlorine, sodium hydroxide, and other chemicals. Lastly, we have the TASA Corporation. TASA Corporation is a global chemical and specialty materials company. It was founded in 1935 in Yamaguchi Prefecture. It began as a manufacturer of chlor-alkali and petrochemical commodities and feedstocks. Today, it produces other chemical-related products. Distinctively, the TASA Corporation is divided into 5 groups: petrochemical, chlor-alkali, specialty, engineering, and support devices. With this, the main products of the TASA company varies from olefins and polymers for the petrochemical group, basic chemicals, MDI and cement for the chlor-alkali group, and organic, advanced, and bioscience chemicals for the specialty group. With the global companies laid out, there is as well a company in the Philippines for the chlor-alkali industry, which is the Mabuhay Vinyl Corporation, the lone chlor-alkali producer in the Philippines. It is the country's manufacturer of caustic soda and hydrochloric acid and the only company that produces chlorine in commercial quantities in the nation. The company was founded by Judge Guillermo B. Guevara in 1935 and has been operating for over 49 years. It had stopped its operation during the World War II, yet reopened in 1955 and reorganized to focus on producing chlor-alkali and polyvinyl chloride or PVC. In addition, it supplies more than 50% of the country's requirement for sodium hypochlorite. Mainly, their products involve caustic soda, hydrochloric acid, liquid chlorine, and sodium hypochlorite.
So in this part, I will be discussing the common products of the chlor-alkali industry and its application in the industry. So one of the commonly known products of the chlor-alkali industry is chlorine gas. And chlorine gas, it is well known to be used as a disinfectant. Chlorine is used to treat drinking water and swimming pool water. And chlorine can also be used in the textile industry. In addition, chlorine is used to make PVC. PVC is a plastic which is used in electrical insulations and window frames. In the pharmaceutical industry, chlorine is used as an oxidizing agent. That is why a lot of production of drugs use chlorine. So sodium hydroxide, or commonly known as caustic soda, is widely used. It is used in the production of soaps and detergents. It can also be used together with chlorine to create a certain type of bleach. So in the pharmaceutical industry, sodium hydroxide or caustic soda is used as an ingredient for pain relievers, anticoagulants, and cholesterol-reducing medications. In addition, sodium hydroxide is also used to control water acidity because of its basic properties and remove metals from water. It is also used in the production of glass and ceramics. So sodium carbonate, or commonly known as soda ash, has a lot of different purposes, primarily in the manufacturing industry. Soda ash is used as a pH adjuster because of its high alkalinity. So in this, soda ash is used in the production of glass, paper, soaps, and detergents. In addition, sodium carbonate or soda ash is also used as a water supplement.
In this part, I will be discussing the process flow diagram of the production of chlor-alkali. The chlor-alkali industry refers to the industry that produces chlorine and sodium hydroxide, or also known as caustic soda, and alkali. Moreover, hydrogen is obtained as a byproduct in the chlor-alkali production. A while ago, there were 3 types of electrolytic processes that were mentioned in the production of chlor-alkali. First, we have the diagram here of the diaphragm cell process. So presented here is the simplified block diagram for the process. So first, water and sodium chloride, as seen here, are combined to create the starting brine solution. And then the brine undergoes precipitation and filtration to remove impurities. Heat is then applied and more salt is added. Then the nearly saturated purified brine is heated again before direct electric current is applied. The anode is separated from the cathode by a permeable asbestos-based diaphragm to prevent the caustic soda from reacting with the chlorine. The chlorine produced at the anode is removed and the saturated brine flows through the diaphragm to the cathode chamber. The chlorine is then purified by liquefaction and evaporation to yield a pure liquefied product. On the other hand, the caustic brine produced at the cathode is separated from salt and concentrated in an elaborate evaporative process to produce commercial caustic soda or sodium hydroxide. The salt is recycled to saturate the dilute brine. Then hydrogen is removed in the cathode chamber and then cooled and is purified by removal of oxygen, then used in other plant processes or sold. Next, here we have a simplified block diagram for the mercury cell process. So, to summarize, the recycled brine from the electrolysis process in this diagram is dechlorinated and purified by a precipitation filtration process. The liquid mercury cathode and the brine enter the cell flowing concurrently. The electrolysis process creates chlorine at the anode and elemental sodium at the cathode. The chlorine is removed from the anode and then cooled, dry, and compressed. The sodium, on the other hand, combines with mercury to form a sodium amalgam. The amalgam is further reacted with water in a separate reactor called the decomposer, so to produce hydrogen gas and caustic soda solution. The caustic and the hydrogen are then separately cooled and the mercury is removed before proceeding to storage, sales, and other processes. Lastly is the membrane cell process. Currently, this is the best available process when we're talking about chlor-alkali industry, since different drawbacks were seen using the previous processes. Worth mentioning is the incident of mercury poisoning in Japan in the year 1972 when they were using mercury cell process. This chlor-alkali process rely on ion exchange membrane to separate the sodium and chlorine ions of the sodium chloride. So in here, the process begins with the pre-treatment of the brine to remove impurities through filtration, and then saturate the salt solution. Next is the second treatment, which now deals with the ion exchange. So the ion exchange membrane separates the cathode side from the anode side. The saturated brine solution that has been treated is channeled to the anodic compartment, while the mineralized water is fed to the cathodic compartment. During the electrolysis, sodium ions and some water permeates through the membrane and enters the cathode compartment. Chlorine gas is formed in the anode compartment. On the other hand, in the cathode compartment, water molecules are electrolyzed, releasing hydrogen gas. The hydroxyl ions will combine with the sodium that permeates through the membrane to form sodium hydroxide.
For this part, the production rate and other statistics about the chlor-alkali industry will be discussed. First, the list on the left is composed of the major producers in the chlor-alkali industry, and it can be seen that Olin Corporation is at the top, which is a company in the United States. It was followed by the Belgian company named Solvay SA. The next is Tata Chemicals Limited from India. The United States is not only on the top of the list, but at the same time is found as the most dominant country for these known major producers as seen, which implies that most production of chlor-alkali products come from US, while there are also a few from Europe and from Asia. There are 4 well-known major manufacturing companies in total for the US. And the figure on the right, specifically for chlorine productions, in which chlorine is a product in this industry, the top producing country is China, followed by India, and the US is the third most producing region for chlorine. With this, the next chart representing the production of also another one of the main products in the chlor-alkali industry, which is caustic soda, found in the United States from the years 1990 to 2019, is presented in the figure. The caustic soda or sodium hydroxide manufactured throughout these years has the range of approximately 10.8 million tons to 11.9 million tons, except during the year 2000, where the increase in production had accumulated the largest amount of 13.5 million tons. Production in the year 2013 was the lowest, where 10.8 million tons of caustic soda were created. The most recent year in the graph is 2019, which had the total production amount of 11.63 million tons, slightly less than that of the previous year. The next figure presents the fraction distribution of the consumption of caustic soda in the global scale. This consumption is seen to be the highest in China, where it is known that most manufacturers and producers of various industries are being held. It almost had 50% of the total consumption and is greatly larger compared to that of the others. United States and Western Europe follows after, as well as Southeast Asia and India. Other countries that are not specified has collectively used up large amounts of this substance also. And soda ash in the next graph is another product from the chlor-alkali industry, where it is commonly used in establishing infrastructures. Its production globally from 2010 to 2020 is presented in the figure, where a significant decrease is seen on the year 2020, having only 52 million tons. This may have been an effect of the pandemic outbreak, as according to the article of Hancock in August of that year, COVID-19 brought a negative impact on the industry of soda ash, decreasing the demand of the product as well as the production amount. The amount manufactured per year starting from 2010 has gradually increased, and it had reached the highest in 2018, gaining 57 million tons of soda ash produced, and the amount in 2019 has also almost retained the quantity.